Okay, so this is the homework help session with Kalen, and he was asking about graphing graphing quadratics from both what I call vertex forms, and then also see how to graph one in standard form as well. First thing I'm going to do, I'm going to try to go grab a little graph so that I don't have to do some awful hand-drawn graph here. Let me see if I can get a graph posted on the whiteboard here. Give me just a second. And I'm just going to make these problems up so they're probably going to be awful. That's usually what happens when I try to make a problem up.
Nothing really comes out correct there.
Yeah, it's not all nice and neat when I try to make it up. So, let's see, I'm copying. Maybe, just maybe this will work. Please, let it work. Let it work. Paste page. Let me try it one more way. Let me take a picture of it. Maybe this will work. Okay, and okay, I see a space for it, but not the actual graph. You're not seeing a graph, are you? Are you seeing anything on the whiteboard?
No, ma'am.
Okay. Try it.
The graph, I did a graph. If you want more art, take it and
Ooh, that's strange. Hang on. Crazy. Okay, that's not what I expected to have, but I got a graph here for you. Oh wait, now it's moving. Oh, I can put it off to the side. Can you see that?
I don't see a graph.
You don't see anything?
Not. Is it supposed to be on this white space right here?
Yeah.
Okay.
Yeah, it is. Okay, we're just going to do it hand drawn. Okay, so let's go ahead and get started so we don't waste any more of your time. I appreciate you meeting with me today, Kaylin.
Oh, no problem. I appreciate you.
Absolutely. Okay,
I don't see it anymore.
I'm just gonna see. I told you this was gonna be bad. There are my axes. Okay, so vertex form for a parabola is f of x equals a times x minus h squared plus k, and that is where hk is the vertex of the parabola. Notice right here, let me get a bigger pen so it's really noticeable. Minus is in the form there. So whatever is just sitting in the position of the h is the x coordinate of the vertex. For example, if we have a function that looks like this, f of x, by the way, you are seeing what I'm writing on the board, right? Okay, very good.
Yes, I am.
Okay, so say we have f of x equals negative x plus 4 squared minus 2. Well, since minus is in the form, okay, so since minus is in the form, we would have to rewrite this as f of x equals negative x, and I'm going to get another color here to really make this prominent, minus negative 4 squared minus 2.
2.
Presentation.
What presentation?
I did it like
That's okay.
Sorry.
So since,
Okay, so you said the negative 4.
so since
okay.
minus is in the form, if you see plus, you've got to put the minus back in there, and the only way that plus could have happened if it had been a minus negative. Does that make sense?
Yeah, so it's going to come out to be
Yes,
x minus 4.
So the vertex of your parabola now shows up in the form as negative 4, negative 2, even though this is the way you're going to see it written. Okay.
Okay.
So you understand why that 4 is negative then. Very good.
Yes,
all right, so with both of the forms, what you have to find is the same thing. The only thing that's different about the methods is the way you find the vertex. With this particular form, the vertex is sitting right there for you to take. With the other form, you have to find the vertex. So those are the only two differences. So we'll go ahead and go through the process with this one, and then we'll look at one in what I've always called standard form, which is ax squared plus bx plus c. So the first step in this process is to determine if your parabola is opening up or if it's opening down.
And that's where you do the negative
That's the other form, vertex, x coordinate of the vertex. So here, pardon me, this is where you look at a, your a value in front of your function there. So if that a value is positive, this thing opens up. If that a value is negative, this thing opens down. So with our particular example here, I have an understood negative 1 in place of the a. So in our case, a is equal to negative 1, which means this parabola is going to be opening downward.
From negative 4 to negative 2.
Yes, because that's the vertex, yeah.
Gotcha, so that's the highest point.
The vertex is either the highest or the lowest depending on how it opens. Okay, very good.
Okay.
All right, so that's the second step, is to either identify or find, depending on what form you're using, your vertex. So in this case, we've already identified the vertex. The vertex is negative 4, negative 2. I could actually go over to my graph already. 1, 2, 3, 4, 1, 2. Oh man, this one's not going to have X-intercept. I knew it. I knew if I made it up, something would screw up in it. Let's scratch it and make it positive. Let's scratch this negative here.
Okay.
And so we'll call a positive 1. No, that doesn't change the vertex. It doesn't change the vertex at all. All I'm changing is the a. I'm just, I'm just gonna delete that I had the a negative there. Whoa. Let's see. Whoa, what the heck is that? There we go. Okay, so we'll pretend that this is positive the whole time, which means that our parabola actually opens upward. So a is now equal to positive 1. I'm so sorry. I knew that was going to happen to me, though. At least I warned you. All right, now a is opening up. All right, or the parabola is opening up because a is positive. So I can go ahead and now plot my vertex. -4, -2. So there's my vertex, and hang on, let me give myself a little more graph now. -4, -2, -5, 6, 7, 8. All right. So first step is always determine how your parabola is opening. Second step is always find your vertex. The third step, and this is why I changed what I just did, is to identify your x-intercept.
To know where it'll cross.
Yeah, and this one, since it was opening downwards and it was in the third quadrant, it wasn't going to cross the x-axis, and I didn't want to do that as an example. It can be done, but those zeros, which is what you call them, they're imaginary, and I didn't even want to go there right now. So to find the x-intercepts, you always plug in 0 for, oh, that's terrible. Hang on. That's just my text message. Plug in 0 for y, which is the same thing as f of x. So to find the x-intercept for this particular problem, I'm going to solve the equation 0 equals x plus 4 squared minus 2. Is that good so far? All right. All right, well, we'll go ahead and do that. Now, I could multiply this thing out and run it through the quadratic formula to solve for x, but since this is in this particular form, I can use the square root property to solve it. It's a little bit quicker with this form. So to do that, I add 2 to both sides and get 0 equals x plus 4 squared, and then I come back, oh no, 2, I'm sorry, jeez, I swear I'm not a complete idiot, I swear it. Okay, maybe today, but not usually. 2 equals x plus 4 squared, take the square root of both sides to undo that square, and I get positive, negative, square root of 2, you have to take into consideration both, equals x plus 4, because squaring a square, or taking the square root of something squared just undoes that. Those are inverse operations. And then I subtract 4 from both sides. You following?
Yes.
You good? Okay.
Yes. Yes.
And I end up with -4 plus or minus the square root of 2 is x. So it's not going to be a nice, neat number, but we can get an estimation of what those values are. So we have -4 plus the square root of 2, and let me grab my calculator. Because I don't fancy doing work like that in my head with irrational numbers. It comes out just about as good as when I try to make up a problem off the top of my head. And of course my batteries are telling me that they're low. Why not? All right, square root of 2. -4 plus the square root of 2 is approximately, I'm going to change these to squiggles to say approximately, -2.6. And -4 minus the square root of 2 is approximately -5.4. So, what you have found going through this process is where this thing crosses the x-axis. You found the x-intercepts by plugging in 0 for y. So I can go ahead and plot those. So I've got one at a little more than -2.5, so maybe right here. And I've got one at -5.4, so almost -5.5. You good so far? All right. Whoa, I promise you I didn't do that. My pen acts crazy with this thing sometimes. Here we go. All right. The last step of the process, well, before you actually graph the parabola, is to identify the y-intercept. And you do that the exact opposite way you identified the x-intercept. You plug in 0 for x. So basically I do f of 0 to find that. So I will write that out for you. Okay, so I'm going to do f of 0, which is 0 plus 4 squared minus 2. So that is 16 minus 2, which is 14. Okay, so way up here at 14 on my makeshift graph is our y-intercept. Now I'm ready to graph the parabola. So it looks something like this. Does it? So basically 4 major steps before you graph. Determine if it opens up or down. Find your vertex. And in this particular case, it's just sitting there for the taking. The other form is where you have to find it. Third step, this is usually the most involved. That's finding your x-intercepts, because you're basically solving the quadratic equation to do that. And then the fourth step is your y-intercept. And then you just graph your parabola from there. It takes 3 points to graph a parabola. So you always have to have your vertex. Now, let's say this thing did open downward, like we originally had happening. Let me just give you a little visual here. Say this thing went like this. And you determine your vertex. You see that there are no x-intercepts, but you get your y-intercept. If you can get your y-intercept, there will always be a symmetrical point that has the same y value. How do you find where that is? All you need to do is figure out how many units to the left or to the right you had to move to come out at that y value. You go to the opposite side of the parabola, move those same units, and you're going to have that y value come out at that same horizontal position. Does that make sense? Okay, so that would be your 3 points. Yes. Graph your parabola, you're done. Okay, so that's for a times x minus h squared plus k. Now let's look at the other forms that parabolas can be in. Do you need anything else off this page right now? Okay, I'm going to clear it.
No, ma'am.
And the other form is when it's written in what I've always called standard form, ax squared plus bx plus c. So, which that makes sense because standard form for a polynomial function is always in descending order like that. So I've always seen the book called this standard form. Your book calls the other one standard form, but that's just silly. All right, let me draw us another terrible graph over here. Okay, and I'm actually going to do some legwork here and find one that works out nicely for us so that it's not terrible with us trying to graph it. Let's see. Okay, let's look at f of x equals x squared plus 2x minus 3. Okay, so the first step is the same. And this A in this particular form is the same A from the other form. So the first thing you're going to do is see if you have a positive A, that thing opens up. If you have a negative A, that thing opens downward. So we have a positive A in this case. It's understood to be positive 1. So this particular parabola is going to open up as well. Good so far? Okay.
Great.
All right. Second step, the vertex. Okay. So in this particular form, you have to find the vertex. And you do that by calculating the x-coordinate with negative b over 2a, and then to get the y-coordinate, you just plug in the x-coordinate into the function. So f of negative b over 2a. All right, so in this case, for x-coordinate, negative b over 2a, I have negative 2 over 2 times 1. Which gives me negative 2 over 2, or negative 1. So far, I have figured out that my vertex has an x-coordinate of negative 1. You good so far? Okay, to find the y-coordinate, you just plug that x-coordinate into the function. So, it sounds like you're pretty popular over there this afternoon, Kaylin.
Oh, no, I'm talking to you, and people think I'm answering questions.
Okay, so when I plug in negative 1 into the function, I have negative 1 squared. Be careful when you're plugging a negative in. Make sure you put it in parentheses because it makes a difference. Negative 1 squared is positive 1 minus 2 minus 3, which is negative 4. So my vertex is negative 1, negative 4.
Okay.
I'm going to go ahead and plot that since I know it. Negative 1, 1, 2, 3, 4, negative 4. So there's my vertex. Third step is x-intercept. So you're going to plug in 0 for y, or 0 for f of x. So in this case, I've got 0 equals x squared plus 2x minus 3. And it just ends up with a quadratic equation that you have to solve. With this particular one, you could factor it and use the zero product property. But the quadratic formula always works with solving these things as long as you can get it into the form ax squared plus bx plus c. I'm that entertaining, huh, Kay? Just kidding. So I'm just going to plug it into the quadratic formula to solve. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And let me just give myself a little barrier here. All right, so I'm going to come up over here to continue. X equals -2 plus or minus the square root of 4 plus 12 over 2. -2 plus or minus the square root of 16 over 2. -2 plus or minus 4 over 2. So we have a plus and a minus. So -2 plus 4 over 2. -2 minus 4 over 2. This one ends up being 2 over 2, which is just 1. And this one ends up being -6 over 2, which is -3. So there are my x-intercepts. I have one at 1 and one at -3. Okay? All right,
Okay.
the last thing before you graph the parabola is your y-intercept. So the fourth step is your y-intercept. And you just plug in 0 for x, so you do f of 0. F of 0 is
0 squared plus
0 squared plus 2 times 0 minus 3.
So -3.
So -3. Yep.
-3.
Put my point there.
2
And now I'm ready to come back and graph my parabola. It's going to look pretty bad because it's a hand-drawn graph, but you get the point. And you just do your last spot check. Yay! Looks awesome, Kaylin. So last spot check you'll want to do, go back to your first step and say, okay, this thing was supposed to be opening upward. Look at your graph, make sure, yes, I'm good, going through my points, and that's it. So the only difference in the two methods is how you get the vertex.
Okay.
That's
Okay. Because in the other one, since the way it's laid out, the vertex is already
yes.
pretty much given. So in this one, you actually have to do a formula for it, and that's the -b over 2a. Okay. Okay.
You good? Excellent. Well, thanks for joining me this afternoon. I will get this posted as soon as I can, as soon as I get my email confirmation of it, and have a good afternoon. You're welcome.
Okay,
I'll
thank
see you,
you so much.
Kaylin.
All right, you too.